Hello and welcome back. In this video I'm going to continue the configuration of mpls, which I started in previous video. Like I said, this is not going to be an in-depth mpls configuration. This is just a normal simple L3 VPN configuration because we are in BGP part of the course. So in previous video, as you saw, I configured LDP on all the interfaces. I showed you some of the verification commands, and in the end, I didn't show you the labels. As a matter of fact, I just remembered that I didn't show you the mpls forwarding table, which is going to show you the labels. But let me just say terminal width is 256 so that you can see this in a better format. You can see that these are the forwarding table for mpls that we have just seen here. Now the thing is, most of the labels that you see here is number 3, and we are going to see in mpls part that number 3 means pop label. The reason for that is we are not going to do any exchange, because router 18 is going to be next to the last router in my network. So that's going to, because I don't have many routers in between, so all I'm going to do is to assign the labels on router 15 and then pop them on router 18 and then send the packet without the outer label to router 16. The inner label is going to be removed on router 16 based on the VRF that we are going to create. So that's okay. But if I just go to, for example, to one of these PEs and say show mpls forwarding table and hit enter, here you can see that there are some out labels here which are going to be assigned for each one of these FECs, and we're going to pop them of course later. And this 3, like I said, means implicit null, which means that we are going to pop the label. Okay, so far everything is okay. I'm going to go to router 16 and 15, which are my PEs. I'm going to create a VPN v4 address family and activate these neighbors under that. So on router 16, I'm going to say router BGP 300. It is 300. I'm going to create address family VPN v4 unicast, and under that I'm going to say neighbor 15 15 15 15 is going to be activated. Now the thing is, because I'm going to send some VRF targets to the other side, or route targets to the other side, and they are extended communities, I just want to make sure that extended communities are enabled for that. Let's just commit this configuration. And I'm going to say show run router BGP. For now, I just want to show you that this is what we have so far. You can see that this is activated. Now if I just say this neighbor, and after that see the options that we have, send community is one of them. I just want to make sure. So I'm going to go with send community, and extended is going to be the one which I want to have. And here it says that this BGP is already enabled. Like I said, this is just to make sure, and nothing is going to be committed. So if I just say commit, it's going to be say nothing to be committed. So that's going to be enough for me. And on some of other platforms, this is by default enabled, like what we have right now here. So on here, what I did is this one. I enabled this for router 15. Let's do this on router 15 for router 16. So I'm going to say router BGP 300. My address family is VPN v4 unicast, and under that I'm going to say neighbor 16 16 16 16. I'm going to activate it, and with that, I showed you that extended communities are going to be sent, so no problem with that. So if I say show IP BGP neighbor 16 16 16 16, it should say that this capability right now is enabled. So neighbor capability is VPN v4. That is exactly what I'm trying to do here. So this part is done. This is going to create the tunnel between router 15 and router 16. So that is what exactly is going to make sure that we do not really want to have BGP inside our autonomous system. The only BGPs neighborships is going to be between PEs here. Okay, so let's create the VRF. That is the next part of our configuration. VRFs are going to be configured on PEs again. So PEs are going to be the intelligent devices in our network, and they are going to connect to multiple customers. For each one of the customers or partners or whatever network that we are going to, be transit for them, I'm going to create a VRF for them. For now, in my network, of course, let's say that AS400 and 200 are two branches of the same company in different parts of the country, and I am the network which I'm going to provide transit for them using mpls. So I'm just going to create a VRF for both of them with the same values. So let's go to P's on router 15 and router 16. Let's create the VRF. So I'm going to say exit, okay, and another exit, of course, to go to global configuration, and I'm going to say IP VRF, and let's say that this is going to be called customer 1. My IP VRF customer 1 has a route distinguisher configuration. Again, we are going to talk about this in detail later, but let's say that the route distinguisher is something like an 8-byte value, which I'm going to attach to each one of the prefixes to just make it unique. Let's say that, for example, there are a bunch of balls, billiard balls, inside a bucket. So I just want to make sure that the set of billiard balls that belongs to me can be separated from the set of balls that belongs to you. How can I do that? I can just put a mark on the balls. For example, a red dot on mine, a blue dot on yours, and based on that I can just say that, for example, this number 8 is mine, this number 6 is mine, this number 6 is yours. So I can have identical numbers, like identical prefixes, but based on the route distinguisher, which is an extra tag in the end of that prefix, I can just tell this is for customer 1, this is for customer 2. Okay, so route distinguisher is something like that. So that's going to give us a big bucket, but tags for everything that we put in there. Now, for the other part, we need to configure something like a route distinguisher. A route distinguisher says, route target. Route target says where I'm going to, send and receive the traffic. As a matter of fact, this is going to create some kind of policies for us. And based on this, I'm going to say whatever I have here could be exported to the other branch of mine only. This means that my prefixes could be exported to the other branch's routing table, and their prefixes could be exported to my routing table. So I'm going to just create that here. And this could be created with route target value. Route target has an export and import policy. If you say both, they are going to be the same. And just for the sake of simplicity, I'm just going to go with both. And I'm going to just add this value to that. Now, this value doesn't have anything to do with route distinguisher. This is something like a policy implementer. So I'm going to do this here, just for the sake of simplicity. So now that I have created this, I can just go to each one of the interfaces, and I can say this interface belongs to this specific VRF. Something like, assign an interface to each one of the customers. That would be easy again, and to do this, first of all, I just want to make sure which interface belongs or connects to this customer. In my topology, Ethernet 0 is the interface which I'm going to configure on router 15. So I will go to interface ETH 0. Before doing anything, I just want to say show run in interface ETH0, because I just want to make sure that later I'm not going to lose any kind of configuration. Here I'm going to say IP VRF forwarding is cost 1. So this is going to apply the VRF forwarding to here, apply this interface at VRF. So I'm going to say commit. And here is the interesting part. It says that IP address is now removed. That is why I did this show run, because now I can just copy this and paste it here without having to remember what the IP address was. I'm just going to say commit now. Okay, now that this is done, I'm going to show you something interesting. You know that this Ethernet 0 directly connects to this interface on router 14. So on router 14, I can just say ping 10, 14, 15, 15. And the ping should go through if there is no problem. Let me see if there is any problem on here. Maybe I have not configured this, or maybe something else. Show IP interface brief says that I have show this 10, 14, 15, 14 interface, which is up and running. On router 15 now, if I say show IP interface brief, says that this interface ETH0 is not having any configuration. And it says that although I just committed this, but this has not received the IP address. That's funny. Let me just see why this is true. Address is assigned by DHCP client. I shouldn't have such thing. Do show run interface ETH0. Interface ETH0. IP address is going to be 10, 14, 15, 15 / 24. Commit. Do show run interface ETH0. Why is it not accepting the address, although it should? Let's do something. This might be a bug in virtualization. And if I just say show transaction current, it says that this is going to be applied. And if I say commit and now do show run interface ETH0, it is not committing the configuration to ETH0, which is not good. So if I say do show interface ETH0, it says that the interface does not have label switching, which I don't really want it. It says DHCP client is disabled. Let's just do something. Interface ETH0. I'm going to say IP address is going to be DHCP. Hit enter. Commit it. Do show run interface ETH0. Okay, now I'm going to go back and assign the actual IP address that I want to have. So now I'm going to commit it and now show the configuration. Now it is working. So this is just a bug in the virtualization. I'm just going to keep this so that you can see that there are some problems during virtualization which you might encounter in real world. Of course, this is not going to happen. So what you need to do is to just do some tricks like what I did here and just continue. So let's go back to router 14. And now if I just ping this, ping is going to true. So what I wanted to show you is this is not going to work on the other side, because if I say do ping this, it is going to say, okay, I don't know where the network is. This is not reachable. But if you say ping VRF cost 1 and then say 10, 14, 15, 14, let's say like this, and ping, and after that I'm going to say 10, 14, 15, 14, and after that I should say VRF cost 1. Now the ping goes through. Why? because the interface is part of this VRF, and now I am trying to use that VRF to get to the destination. This is exactly what I try to say here. Okay, so show run IP VRF and show run VRF actually cost 1. I'm going to do the same thing on the other side. So I'm just going to copy this and go to router 16. And router 16, I'm going to create this VRF. Although it doesn't have to be the same, but I'm just trying to be super simple in here. And again, the interface which is connected to the other side is ETH0. So I'm going to say ETH3, ETH3. So I'm going to say do show run interface ETH3 once again, because I just want to know that this interface IP address is this. I'm going to say IP interface ETH3 IP VRF forwarding is cost 1. Then I'm going to apply this IP address again to this. Then I'm going to say commit. Okay, do show run interface ETH3. It says that now I have the IP address. So if you see that these are some little tricks that you have to do on virtualization environment just to make sure that nothing is going to break. Okay, so I have done this here, and if I say show run router BGP, we have this VPN v4 unicast enabled here, so everything is almost done, and I should only do one thing. Now there is only one thing left, and that is the adjacencies that I have with other autonomous systems, which is in this case my customer. This adjacency is now through a VRF, because I am connected to an interface from router 15 points of view. That interface is considered under specific VRF. The same thing is here. So I need to redefine the neighbor under this specific address family. I need to create an address family for this. So let's go back to router 16. For now, you can see that this neighbor is here. But if I just say do show IP BGP summary, this neighbor would not be there anymore. To show BGP summary, it says that that neighbor now is no longer active. So what I'm trying to say is I need to create that a specific address family. So I just go under this router BGP. I'm going to say address family IPv4, but not just global IPv4. I'm going to create this for a specific VRF. For any customer, I have to create this separately. So IPv4 VRF cost 1. Now I need to create that neighbor one more time here. This neighbor is under remote AS 200, and this neighbor should be activated. If I want to advertise anything to this neighbor, I can just do it here, but I'm not going to do anything other than just doing this and committing this. Now, if I say do show IPBGP summary, now you can see that this is now an extra thing that we have just created. This one should be removed because this doesn't exist under the global configuration. This exists under this VPN, and we have sent and received the prefixes. So I'm just going to remove this from my global configuration. This was my previous configuration. You see that this is under global configuration. Now if I just say show run router BGP, you can see that I have this under customer here. So I don't really need this one. So I'm just going to say exit address family under router BGP 300. I'm just going to say no to this one. No, less and commit this. Okay, so now if I say do show IP BGP summary, you can see that this is for my global, which is an IPGP, and this is for VRF. Everything seems to be good. And the same thing should be done on R15, of course. If I say show run router BGP, now I'm going to remove this specific neighbor, which is this one. So I just go to configuration mode, router BGP 300. I'm going to say no this neighbor. I'm going to create address family IPv4 for VRF cust 1. And I'm going to say this neighbor is here and this neighbor should be activated. And I'm going to commit this. And with this, my simple configuration is going to finish. Do show IP BGP summary. Now it says that I have the adjacency created for me successfully. Okay, now let's go back to here. Does my customer have end-to-end connectivity from this branch to this branch? I know that right now these are in different autonomous system numbers. That's okay. I know that BGP by default does redistribution, and I have no problem about redistribution. That's okay. The same thing is going to happen here. So I should have complete information about the routes from the other side on this side and vice versa. So if I just go to router 14 and say show IP, let's say BGP, and hit enter, I know every prefix is from the other side. And it goes through AS300, which is the service provider. Can I ping it? If I say ping this 8888, and if I source it from my own loopback interface, the ping goes through without any problem. So now that we have created this simple configuration of mpls, as I told you, in L3 VPN, the routers in between don't have to know anything about BGP prefixes. They don't have to have the trouble of, redistribution and holding a big BGP table. What I did is I just created this tunnel inside here and using a specific address family. And with that, the connectivity of the two parts have been kind of created for me. So that's it, and I hope this has been informative for you. See you in next videos.